This is 4-nitroaniline, which is a chemical that's commonly used to make things like dyes in pharmaceuticals. But I just want to burn it because it has a cool reaction. To make this happen, I just have to add some of it to a dish, along with some sulfuric acid. Now I just have to heat it with a Bunsen burner and turn it into a bubbly mess. It's supposed to make a big snake thing, but this is just kind of sad. I'm gonna try to do it again on a larger scale and see if it works better. It was kind of the same thing, but bigger. The last time that I did this, I did it in a beaker, and it seemed to work a lot better than this dish. Over the last year, I've collected a small amount of gold powder, and I've decided to melt it down. To do this, it's actually quite easy, and I just have to put it all into a crucible and sprinkle on some borax. Then, if I blast it with a torch, it'll all eventually melt. I really thought I was going to be left with a super small bead, but this is actually pretty decent. It's barely just a gram, and at today's current price, it's worth about $52.
Yeah. 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 Yeah.
Mercury is the only metal that's liquid at room temperature, and it's able to easily form alloys with most other metals. In chemistry, it's pretty common to combine sodium and mercury, which can be fun and a bit dangerous. I did this a while ago on my YouTube channel, and I basically just shoved sodium metal into mercury. The reaction generates a lot of heat, and it's usually enough to boil the mercury and light the sodium on fire. Today, I'm going to be showing you the classic barking dog experiment that I did a while ago on my YouTube channel. To do this, I just have to fill a tall cylinder with nitrous oxide gas, which is the same thing that they use at the dentist. Then after that, I can add a few drops of a solvent called carbon disulfide. Now I just need to cover the top and shake it around a bit. I should now have a mixture of the nitrous and the carbon disulfide, and all I have to do is light it on fire. This is a cube of aluminum. It's pretty light, and it barely weighs a pound. And this is a cube of tungsten, which is one of the densest metals. It's the exact same size as the aluminum one, but it's kind of crazy because this one weighs over 5 pounds. Its density is almost the same as gold, so a block of gold this size would weigh almost exactly the same amount. And this is a 42-pound tungsten cube. It has nice sharp edges. Oh god, you really, oh no. Oh. This is sodium metal. It's stored under oil because it's very reactive to moisture and air. Most metals are hard, but sodium metal is really soft, and you can squish it just with your fingers if you squeeze really hard. Metals are usually shiny, and sodium metal is as well, but because it's so reactive, it quickly tarnishes. But because it's so soft, it can be easily cut with a knife, and on the inside, we can see the nice and shiny metal. After only like 10 seconds, it's already tarnished. About a year ago, I bought this powder from Russia. It's not sketchy though, and it's just a chemical called CPPO. Okay, that's still kind of sketchy. But CPPO is actually just a chemical that's used to make glow sticks. I've decided to finally use it and to make some giant glow stick thing. Just add a random amount here. Then we add a sprinkle of this, which is sodium acetate. Then we also add a solvent, ethyl acetate. Then we add some dye to it, which will give it its color. The last thing to add is some hydrogen peroxide. This is actually way brighter than I thought it would be. But anyway, this is probably going to keep glowing for a while. Actually, that's pretty cool. So I needed a radiation sign, but I don't have a color printer. But thankfully I have fluorescein, which is a really strong yellow dye that's commonly used to make highlighters. To make an ink out of it, I just have to add a small amount to water. Now to color in the sign, all I need is a cotton ball. Okay, so the sign is done, and now I just need to cut it up and slap it on my radiation cabinet. So I have some really dirty lead, and it needs to be cleaned. To do this, I just have to melt it, and I put it on a camping stove. As it heats up, it reacts with oxygen in the air, and it slowly gets covered in yellow lead oxide. When it's fully melted, it's all nice and shiny, and all that lead oxide and other junk is just floating on top. Now I just need to carefully pour the lead into some water, and hopefully leave all that other crap behind. Okay, so it's basically done now, and I just need to pull it out of the water. This is my radiation cabinet, and here I have my uranium glass. I made it myself, and it actually contains uranium. What's cool about it is that it fluoresces under a black light, and it lets off a really nice green color. Because it contains uranium, it is radioactive, and this can be detected using a Geiger counter. Every time it beeps, it's detecting a radioactive particle, but it's actually not that bad. This is because there isn't much uranium in it, and it's nothing compared to pure uranium. This is a mineral called pyrite, and it kind of looks fake, but it's actually completely natural. Pyrite's also sometimes called fool's gold, and it's able to form in a few different ways, but I think that this cube form is the most interesting. What I find weird is that it's shiny and cold like a metal, but it's not a metal at all. It's also very brittle, and it can break quite easily. Phosphorus is an element that can come in a few different forms. One of the most reactive forms is white phosphorus, and a while ago, I was able to get some chunks of it. It's stored underwater to protect it from air, and the moment I take it out, it starts smoking. This is because it's reacting with oxygen and letting off phosphorus oxides. It's often used to make large amounts of smoke, but it's also sometimes used as a weapon, which is a bit terrifying. This is because white phosphorus is not only very toxic, it's also super hard to put out when it's on fire. To test this, I'm just going to light this small piece. It immediately starts burning and splashing, but I can put it out by just smothering it, which makes it seem not that bad. However, because it's so reactive with air, this is what happens when I take away the dish. A little while ago, I showed you guys some powder that I got from Russia, and I used it to make a giant glowing thing. What I didn't tell you was that around the same time, I also got a bunch of pills from Russia. But this, unfortunately, isn't sketchy either, and they're all just made of something called calcium gluconate. It's meant to be taken as a calcium supplement, but what's cool about it is what happens when it's burned. It breaks down into calcium oxide, carbon dioxide, and carbon, and it grows as a weird snake thing. So today, I've decided to make a really unstable chemical called manganese heptoxide. To do this, I just need to start with some sulfuric acid and then sprinkle on something called potassium permanganate. It makes this angry green liquid that can spontaneously decompose just by touching it. It also reacts with almost anything organic, and this is what it does to a cotton ball. It's even more violent with liquids, and this is what it does with ethanol and acetone. This is bromine. It's chemically very similar to chlorine, except chlorine's a gas and bromine's a liquid. It also lets off a lot of nasty orange vapor, and this is why I sealed it in glass. Bromine's really dense, and it's more than 3 times as dense as water, and this makes its vapor really heavy. Bromine's notoriously difficult to store, and if I just put it all back into a bottle or something, it would damage everything around it. So I have to seal it again in a glass ampule that I made from a test tube. So today, I'm going to be making some liquid oxygen. Oxygen's normally a gas, but it can be turned into a liquid using liquid nitrogen. When the tube's really cold, I can start to shoot in some oxygen gas. I can't really see what's going on here, but after a few minutes, there should be a decent amount of liquid oxygen. Okay, so by now, it's probably good, and I can take it out. Liquid oxygen is faintly blue, but it's really hard to see here, so I'm gonna put it in a smaller tube. It's still a bit hard to see, but it is definitely blue. Now this is very dangerous, but what's fun to do is to throw a match into it. As a liquid, oxygen is an even more powerful oxidizer, and it can sometimes react explosively. After this, all that's left is just a small part of the match head. Earlier today, I made some liquid oxygen, and I used it to destroy a match, but I still had a bunch of it left over. So I decided to use the rest of it to burn some steel wool. I thought it was all going to disappear, but a lot of it didn't react. The reaction was also apparently hot enough to melt some of the iron. After this, I still had some oxygen left, so I just shot the rest of it onto a larger piece. This is cochineal, which is a parasitic insect that generally lacks self-locomotion. What's interesting about them, though, is what happens when I crush them. They leave behind a lot of nice red powder because they have something in them called carminic acid. This is commonly used to make dyes for foods and in things like lipstick. This is mercury metal. It's one of the only elements that's liquid at room temperature, and it's also very dense. It's even denser than lead, and it can float this bag of lead on top of it. Mercury is known for being very toxic, but in its metallic form, it's kind of okay to touch. This is because, as long as you don't have any cuts or anything, it's not able to go through skin. But it does let off invisible vapor that you can breathe in, which can lead to mercury poisoning. So, even though it is kind of fun to play with mercury and to touch it, I really don't recommend it.